In this video, we're going to talk about topic 10.8, which is the ratio test for convergence. And we'll also be discussing the root tests in this lesson. So how do you use the ratio and root tests to determine the convergence of a series? And I can determine the convergence of the series using the ratio test. I can determine the convergence of a series using the root test. So what the ratio test is that we know we converge if we take the limit as n approaches infinity of taking the a sub n plus 1 series dividing by our original series. So this is putting n sub 1 or n plus 1 in for n, and this is the original. If that turns out to be less than 1, we converge. If it's greater than 1 or equals infinity, we diverge. If it is exactly equal to 1, it is inconclusive, meaning we'd have to pick one of our other tests. This one is great to use with factorials. So if you see a factorial, I would go straight for the ratio test. So I'm going to start by substituting in n plus 1. So we've got the limit as n approaches infinity of 2 to the n plus 1 over n plus 1 factorial over 2 to the n over n factorial. So I probably won't write it out that way again because I know that whenever I have the complex fraction, I have to flip and multiply the second one. So really, I would rewrite that as the limit as n approaches infinity of 2 to the n plus 1 over n plus 1 factorial times n factorial over 2 to the n. Now, I want to see if there is any way I can simplify this a little bit. So I'm going to write this out as the limit as n approaches infinity. I know that 2 to the n plus 1, if I take that apart, technically I'm still in absolute values here. If I take that apart, I am left with 2 to the n times 2 to the first. Because remember, when we are multiplying, we add our exponents. N plus 1 is factorial, is like saying n plus 1, and then we multiply it by the thing before it, which is n, and then the thing before and the thing before. But the reason I stopped there is because now, look, I can cancel some things. So I know 2 to the n cancels, and I know n factorial cancels with n, which means what I am left with is the limit as n approaches infinity of 2 over n plus 1. Which when I plop my infinity in there, I get 2 over infinity, which is equal to 0 and is less than 1. So therefore, this converges by the ratio test.